So for 2024, Sadie, I understand you have some structure, some overarching structure. Last year you had a really cool structure as well. What's the structure this year for your predictions?
Yeah, so this year I think of it like a tech stack, right? Where you have your hardware, your software, your end users. And so I really structured this in terms of a tech stack all the way from the beginning fundamental base stages of hardware. And that really leads me into my first prediction, which is we're going to see an increased demand for data and hardware. And I call this just like data and hardware hungry. And the reason for this is we all know that everyone is trying to get their hands on more GPUs and there's a shortage. Um, but the main reason for this is we have a really well behaved, predictable function of how to improve LLMs today, right? So it's a function of N, the number of parameters in the network, and D, the amount of text we train on, right? Now, this is for just LLMs. It's not all models out there. But that being said, we're not looking at improvements from the different algorithms that we're using. It's pretty tried and true, right? Give it more compute and give it more data and it will perform better. And so I just see the need for hardware and data to continue to increase. And two byproducts of that are one, I think we're going to start to see some innovation in the hardware space. NVIDIA today has been the leader, but they're reaching this demand point. And in addition to that, there's this opportunity where now additional startups are saying, hey, there's so much business in this space. We want to innovate and we want to come into this market. So I think that there's going to be some innovation in the hardware space. And then on that data hunger space, we've seen that with these companies such as OpenAI and Google and Claude, they've scraped the internet, right? We have the base models that have pretty much taken everything from the internet and been used to train on. But now we really need to delve into that area of fine tuning and fine tuning some of the niche areas for these models. And so I still think that there's going to be this incredible hunger for data, but not as much on that mass scrape the internet, train the base model, but more of that fine tuning of the top layer of the model. So that's my first prediction, just an increased still appetite for hardware and data.
For sure. Yeah, agreed. That feels like a really safe prediction. I feel like we're going to be ticking that box off in a year's time. No problem. There is. I mean, there's no question. That is the way that things have been going so far. So, as you're saying there, so the with the modern LLMs since GPT 3.5, and also the Instruct GPT approach that OpenAI published on before GPT 3.5. Since then, we've been using reinforcement learning from human feedback, RLHF, to add this third step onto the LLM training process. So step one is this pre-training. It's unsupervised, so we don't need labeled data for that. We can just take a scrape of all of the internet, as you're saying, and we need to do some cleaning up because you don't want just duplicates of the same information. Ideally, you want to avoid having misinformation. But so you do some cleaning up on all of the internet, but there's no like labels, and you just use that to train up a general understanding of vocabulary in the world across all languages and programming languages and everything. It's wild with so many parameters, hundreds of billions, sorry, of parameters. We can encode all these different meanings. It's just in that unsupervised way. And then the next step is fine tuning. And this had been going on for a few years for LLMs. So GPT-2, GPT-3, of course, GPT-1, and other models around that time. They were fine tuning in a supervised learning way. So you were using a traditional machine learning, supervised machine learning cost function, usually cross entropy cost, to be able to get closer to the kinds of outputs that a model should have given some input. And so this requires lots of relatively expensive data to obtain, as opposed to the that unlabeled data that's used for the pre-training. But it was this third step. So first step pre-training, second step fine tuning. that had been going on for several years. It was a year ago in 2022 with the Instruct GPT paper and then the GPT 3.5 model that was released under the hood in ChatGPT that it's this third step, reinforcement learning from human feedback, RLHF, that was this big step change in how aligned outputs are with the kinds of things that humans would like to see outputs be. And so it's a more nuanced, it's a more dynamic, this reinforcement learning from human feedback is, yeah, more nuanced, more dynamic, more aligned with the kinds of things that humans want than just the supervised learning that had dominated that second step before. So yeah, I don't know. Just a bit of history there, I guess, for people who didn't know it. But in all of these cases, more data is absolutely better at all three of those stages. And as you're saying, we're kind of running out of that first step because there just isn't really much more data to have. But for steps 2 and 3, there's still a huge amount of potential. Um, and so in addition to the data sets going up, it's also the number of parameters, which so we're scaling up by orders of magnitude. And so things like the chinchilla scaling laws give us a sense of how many data, how many tokens we'll want given a certain model size. But that's just for doing it in the most cost effective way. You always want more data, you always want more parameters, you're going to get better results. And so because of that, the demand for GPUs and other kinds of accelerators that are used for training AI models, that is definitely going to go up in the coming year. But all of that said, and I've been talking way too long, I'm so sorry. But all of that is to say that I think also we're going to see in 2024 the first for the first time, I think we're going to see big alternative approaches that require much less data.